So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mask coder this side. So in this video we are going to discuss lecture number 15 of the linked list series. Let us continue the playlist. So we are going to discuss question number 2487 of the lead code, which says we have to remove nodes from the linked list. But there is a condition. What is the condition? The condition says remove every node which has a node with a greater value anywhere to the right of it. That is, suppose this is the linked list given to me, right? 5, 2, 13, 3, 8. Now, if I see, is there any element which is greater than 5 present on the right of it? Right is this direction, right? Is there any element which is present on the right of it which is greater than 5? Yes. What? It is 13, it is 8. Two elements are there which are present, and so I will not take this node. Moving to 2. Will it be taken into the account? No, because 13 is greater than it, 30 is greater than it, 8 is greater than it. So I will not take into account. But 13 does not have a greater element on the right side, so it will be taken. 3 has a greater element, it is 8, so I will not take 3. Talking about 8 does not have anything on the right which is greater than that, so 8 will also be my answer. So my linked list, my answer linked list would look something like 13 connecting to 8, right? Initially my head was here, but now my head is here. How will you do this problem? How will you do this problem, right? So the brute force approach, the brute force approach. What will you do? You will say the given linked list is 5, 2, 13, 3, and 8, right? I want to select the element which does not have any greater element on the right side of it, right? So what will I do? I will just create a dummy node as I create in the other approaches. I will just create a dummy node. Let's suppose -1. This is my dummy node, and I will keep a here. Now what will I do? I will keep my temp here. Now what will I do? I will start from here. Let us say this is B. I will traverse the whole linked list and I will see if any value is actually greater than 5. So my B is here, it is not greater than 5. My B is here, it is not greater than 5. It is greater than 5, sorry. So I will not take this temp. I will just delete this node. I will move here. I will move here. Now my B will go for 13, 3 and 8. As soon as I reach 13, I will see that this value is greater than 2. So I will not take this node also. Temp will come here and I will start by B from 3. I will see 3 is not greater, so B will move forward. I will see 8 is not greater, so B will move forward. B is equals to null. B is equals to null, and I have not found any value that is greater than equals to 13. So I will say this is my answer. This is my answer. So I will just attach 13 to it. A will come here and temp will move to 3 now. Temp moves to 3. I will again say B comes to 8. 8 is greater than 3, so I will not take 3. I will delete this 3 node also. Coming to temp, my B is starting from null, and that means I cannot encounter any element which is greater than equals to 8. So I will attach 8 here. Now A comes here and it is null, right? Now this is my dummy node. I will delete the dummy node and my head will be returning 13, 8. The perfect approach, but what is the problem here? As it is the problem with the most of the DSA questions, the complexity. Every time whenever you solve a question, analyze its complexity, both the space and the time. Okay, so what is happening is, for every value for this temp we are encountering n minus 1. Suppose this is a linked list of length n, right? For the first node we have to see it at in the worst case n minus 1 values, 1, 2, 3, 4, right? For the second case, that is when my temp is here, I have to see 1, 2, 3, that is n minus 2 values. For the third case, I have to see n minus 3 values, right? Suppose at the nth node, I will have to see 0, right? So it is actually running for 1 plus 2 up until plus n minus 1 operation. So it is actually running up till n into n minus 1, n into n minus 1 by 2 operations. So it is actually O of n square. That is not a good sign, right? And what is the space complexity? I'm not using any extra space, so space complexity over 1. I am safe there. I am safe at the space complexity, but I have a problem at the time complexity. I want to reduce it. Is it possible to reduce it? Let us see. So my approach says something else. My approach says something else. The optimized approach of this question is something like this. So I have the linked list 5. It is 2 here. It is 13 here. 3 here and 8 here, right? This is my linked list given to me, right? The first thing says same. I will create a dummy node that is -1. I will name it as dummy and I will assign A to it, right? Now, what is your requirement? What is your requirement? You are ruling out any node. My I am ruling out I am ruling out any node only on the basis of right side nodes, right? This is my first point I have to consider in mind. Only these nodes are actually responsible for the 5's value. Will it be added into the answer or not, right? Now, I am saying that if I have the maximum among each interval, that is I have a maximum among it is 8, 8, 13, 13, 13, right? That is up till 5, 5 till last element, it is 13. 13 is the maximum element. From 2 till 8, it is 13 again. From 13 till 8, it is 13 again. From 3 till 8, it is 8. And from 8 to 8, it is 8, right? So, can I say that if this element value is actually less than this, I will not add it, right? If this element value is actually less than the maximum among all the elements, I will not add it, right? This is my consideration. Okay, so what I will do is I will try to find out the sum before reaching this node. I will try to find out the sum. I will try to find out the maximum, which is 13 in this case, before reaching this node. How? This is my head, so I will have to start from here, right? This is my head, so my start is actually from here. But you are saying that I want 13. 13 is present here. How will I get 13 first before 5? My consideration is I want to get 13 first before 5. How will I get that? How will I get that? So up until now we are actually traversing in this direction, that is left to right. I am saying, what if we travel in this direction? You will say you will have to reverse these nodes, these connections, right? You will have to reverse these connections. Only then it is possible to travel in the direction, right? Because the linked list has a limitation that it can only give me the next. It cannot give me the previous, right? So I will have to change this connection. I said you are actually giving me the answer. I say reverse the list. Reverse the list. Your first step will be to reverse the list. This will be your first step. After reversing, the linked list actually looks like this: 8, 3, 13, 2, 5, right? Now, if you see the intervals, this was 8 up till here, 3 here, 8 up till here, 13 up till here, 13 up till here, and 13 up till here. I say keep a pointer maxi. Keep a pointer maxi. Initialize by 0. Initialize by 0. Currently, this is my head because I have reversed the linked list. I will keep my temp here, right? I have my dummy node as -1. This is my dummy node. I have my A here. Let me change the ink, right? This is my maxi. I say start traversal. Start the traversal. Now 8. I update my maxi. Maxi will get to convert it to 8. Now my condition is if temp value is less than maxi, that means temp has a value greater than it on the right side. It means temp has a value that is greater value is present on right. How can I say present on right? See, you are saying that I am going from left to right, so I can say about left values, but the linked list is reverse, so left actually becomes right. What I am saying is I am keeping a maxi that is like I am here, so maxi will be maximum among here. I am here, maxi will be maximum among here. I am here, maxi will be maximum among here, right? Suppose something like that. So you are saying, I am saying that I like maxi is keeping me the maximum element among the left of it, right? Among the left of the node. But the linked list is reverse. So it is actually providing me the maximum value among the right of it. Are you able to understand? Because of the reversal, the left maximum value is from the right part, not the left part. Okay, so greater value is present on right. If temp value is less than maxi, that means greater value is present on the right. In that case, delete temp. Delete temp. I will not repeat how to delete temp. It is pretty evident. I will keep a node here X. I will move my temp here. I will delete this node. Right? I have explained this many more times in the playlist. So please watch that if you have not watched that. Okay. Otherwise, if that is not the case, then add it into the linked list. Else, add it to answer linked list. That is, I know A will get converted to here. A will come here. Temp will come here. I will break this connection. Right? I will not repeat it again and again. Okay. Okay. So maxi equals to 8 up till now. Moving forward, 3. Maxi is still 8 because 8 and 3 maximum is 8. I will see that this is getting executed. So I will say delete temp. This is not deleted. Temp come here. 13. 8 get converted to 13. I see the else condition is true. I will add it. Right? And then afterwards 13 to 2. 2 also get deleted because 13 is the maximum till now. 5 also get deleted because 13 is the maximum till now. So my answer linked list will look something like -1 connected to 8 connected to 13, right? My dummy is here, my dummy is here, right? So what I will do now, I will just delete my dummy. My head will be 8 to 13. But if I see my answer was looking like 13 8, 13 8. Why? Because it was the reverse, it was the original linked list, but we actually reversed the linked list. So I will say reverse it again, reverse it again, right? So what I will say, it will become 13 connected to 8, and if I'm not wrong, this is my answer, right? This is my answer, this is my answer, right? Okay, so let me concise you, let me briefly concise you with the diagram that what did we do, right? So the given linked list to us was 5 2 13 3 8. This was the given linked list. I said reverse it. In the first step, reverse it. So it get converted to 8 3 13 2 5, right? It get converted to this. I say make a dummy node. I say make a dummy node. So my dummy node is actually here as -1. This is my dummy node. I say keep my A here, my temp here. Now start traversal as we did in the previous way, but make a maxi pointer which is currently 0, right? So my loop will look something like while temp, while my temp is not null, while my traversal is not done. Update your maxi. So maxi equals to max of current maxi and temp value. Okay, so maxi get converted to, this is 8 actually, this get converted to 8, right? Because 8 is greater than 0 obviously. Now my condition will be if temp's value is less than maxi, that means this node should not be added to the linked list. In that case, x equals to temp, temp equals to temp next, and then delete x, right? So what I'm saying is x comes here, temp comes here, and then delete it, right? Okay, this is my operation when maxi is actually less than temp, right? Delete x. Otherwise, as is the case now for the 8 element, else what we will do, you will say a next equals to temp, right? Temp equals to temp next, a equals to a next, and a next equals to null. The standard procedure to add a linked list into the answer linked list, right? A equals to a next. So let us try to dry run it. What will happen? Okay. So I will say my 8 is my maxi right now and temp is also 8. So I will attach it because 8 is equals to 8, not less than 8. Okay. Temp will come here, A will come here, I will break the connection. That is, this connection is broken, right? Temp is now here, A is also not here. Now moving forward, 3. Maxi is 8, temp value is 3. No, it will be deleted. So I will delete this node. I will delete this node and temp will come here. Now 8 to 13, it will get matched because maxi will get updated 13 and else block will run. So a next equals to 13 and a will come here, temp will come here, and I will break the connection, this one, right? A is removed from this direction also. Moving forward, 2, it will get deleted because it is less than maxi. Delete this node, temp comes here. Let me delete the node, temp come here at 5. I will see 5, it is still less than maxi, so delete it also. It is also deleted, and my traversal for the linked list is done, and I am able to find that I am left with -1, 8, 13. A is here and dummy is here, right? Now as usual I would delete my dummy node, so I will say my head equals to dummy next, right? My head will be placed here. I will say delete dummy, that is delete this node with the connection, right? Now because we reverse the linked list, that is why the order we are receiving the answer is also reversed. So return reverse of head. Before returning reverse, make sure to reverse the head, right? So this will actually get returned by 13 8 order, right? And I hope this is clear to you. Okay, so what is the complexity now? What is the time complexity? So as you can see, we first reversed. That took the time complexity of O of n. After that, we actually traversed. Simple, like we actually traversed. That also take a time complexity of O of n. Again, after all the operation, we also reversed for the answer order also. So O of n again. So O of 3n, which actually converges to O of n only in the case of time complexity. But the space complexity is also O of 1 because we are not using any extra space for the whole solution. Right? Now it is time for you to see the code of it. Alright guys, so here we are. So as you can see, I've already copy pasted the code for reverse and the link is provided in the description. You may check it out. Now, because the question has been already been discussed in the playlist only, I have attached the link to the video also in the description. So please watch it. Now, it is time for us to do some work. But before that, please subscribe to my channel and hit the like button if you are able to get any kind of knowledge from this channel, right? Because it really motivates me and I will keep bringing the amazing content to you. Now, moving forward, my first case is to reverse. So head will now change to reverse. That is, reverse the head and give it to me. I have actually reversed the linked list now. Now I will make a int maxi equals to 0. Now after that I will make a list node star dummy as new list node of type -1. And now list node star a for the insertion in the linked list of the answer and temp for the traversal. Star temp equals to head. My loop will run until my temp is not equals to null. So first update your maxi. So maxi equals to max of maxi with temp of value, right? Moving forward, if temp value is less than maxi, that means I will have to delete this node. So list node star x equals to temp, temp equals to temp next, and now delete your x. Moving forward, else case. What is the else case? I will say a next equals to temp, a equals to a next, temp equals to temp next for the traversal, and a next becomes null, right? After this, after the whole loop is done, I will actually get my answer but in the reversed order. Also I will have to delete the dummy node also. So my head, new head becomes dummy is next, and you can safely delete your dummy because its work has been done. Say thank you to it and delete it. Now you will just return the reversed linked list. Let us try to compile and run it. Hope it should work fine. Should not give any error, I guess. It is running fine. Let us try for submit as well. And it is running fine. So thank you for watching, and we'll meet tomorrow with a new video with a new lecture. So please stay tuned, and to stay tuned you will have to subscribe and hit the like button and hit the bell icon also. Thank you. Have a nice day.